back, folks. We are on Unit 10. Unit 10 is titled Systems of Linear Equations and Inequalities. A system is just when we have more than one true at once. So systems are two or more equations. Okay, that's all. Now, we're handling two or more at once, which assumes that they're both true. Two or more, so we might say simultaneous. And I'm going to spell that wrong, but you get the point. Simultaneous. Oh, let me just fix that. There we are. Simultaneous is a hard word to spell correctly. All right, so just so you know, that's what we're talking about. We'll only have two in this class. You can have more. In Algebra 2, you'll handle three variable triple equations. So three equations with three variables each. That's something you will do in Algebra 2. So you need to understand how to do this in Algebra 1. Also, if you get to college and you take the class linear algebra, that is an entire class of basically this, okay? It can get really complicated. They use it a lot with computers and things that handle lots of variables. So that's the long story of where this class goes. But we're just going to do two variable equations. So we're looking at this. The length y of a rectangle is 4 times more than its width. So there's some rectangle, and its length is 4 times its width. No, 4 more than 3 times its width. So if I take its width, x, and I multiply it by 3, and I add 4, I should get the length. The length is 4 more than 3 times the width. That's what we're looking for, just for the record. This is something you need to get good at, is reading something and saying, hey, okay, so I have my width. I need to do 4 more than 3 times that. So 4 more than 3 times the width is the length. And now I have an equation. So we just have to write down what we read. And that's a very important skill. Okay, what do you know about this equation? This is a linear equation because right now it has a slope of, if I write it the other way around, I write the y first, it becomes clear that this is in slope-intercept form. Y equals 3x plus 4. M equals 3, and b equals 4. We know the slope and the intercept of this. It has a slope of 3 and a y-intercept of 4. That's something you can know about it. What must be true about a point that lies on this? Well, anything that says this has to fit, anything that works with these, any x and y will be 4 times more than 3 times the width, right? Y is 4 more than 3 times as much as x, always. That's the list of all the numbers that do work. If we go to graph it, we'll find out that that's the list of all the numbers that do work, where y is 4 more than 3 times as much as x. That's what that line is. So if I go down, we're going to look at it right here. This is it right here. It crosses at 4, has a slope of 3. Let's take a look at this number right here. This right here is the point. 3, 18. 3, 18. No, not 18. What am I doing? 312. No, 313. I'm dying here. Sorry about that. Okay, 313. If I take x and I multiply it by 3, I get 9. And then I add 4 and I get 13. 13 is 3 times as much as 3 times 3 plus 4. All of the numbers on this graph will do that. Even the decimals will do that. That's the power of graphing. All of the x and the y's make this true. All right, so now we're going to go over here and we're going to do our next equation. Now we have our first equation, equation 1. We need a 2 to have a system. So we have the same rectangle. This is the important thing. They should have said the same rectangle, but that's okay. But that's all right. We'll forgive them. What equation represents this situation? A rectangle has a perimeter of 24 feet. Well, if you remember, there are 4 sides on a rectangle. 2 of them are width and 2 of them are length. So I could say P equals x plus x plus y plus y. Just, if I put in the numbers, I know the perimeter is 24, right? And I know that 2x's makes 2x. And then 2y's makes 2y. So this is the formula that we got next. Notice, this is an equation with x and y. And so was the one up here. And assuming we're talking about the same rectangle up here as down here, then we have a rectangle where the relationships of the sides, one side is 4 more than 3 times the other side, and its sides add up to make 24. So if we have a system, we're trying to say, and both of these are true. That's what systems are about, making sure both of these are true. Okay, so what do you know about the graph of this equation? Well, let's see. It's a graph in standard form. Linear, it's linear. Standard form. X-intercept, or y-intercept, I guess, is going to be, well, that's when x equals 0, it's going to be 12. X-intercept is also going to be 12. Now, if you're not sure how I got 12, I plugged in 0 for the other number. That's always how we find intercepts. That'll come in handy in later math too. Okay, so we'll have a line that crosses at 12 up here and at 12 down there. You can notice its slope is -1. There's a way to find the slope here. We divide these guys and make them negative. Just for the record, so 2 divided by 2 is 1, and then you make it negative, and it's the slope. How do I know that? Because you can solve this one for y. So it looks like this. 2x plus 2y. Why am I showing you this? Because you need to be able to do this type of stuff. All right, this is part of the class. I would, if I wanted to solve for y, I would take away 2 x's. And I'm going to put 2y equals -2x plus 24. And then I would divide everything by 2. Now I'd get y equals -1x plus 12. This tells me the y-intercept and the slope. The slope is -1 and the y-intercept is 12. It's the same formula, the same equation, just stands for something else. So now I know the slope is also -1. Okay, so that's some other interesting stuff we could say. So we know how to graph it. What must be true about any point x, y that's in here? Well, technically, x and y will add up to make 12. Why? Because if I double them, they make 24, right? But any x plus y will make 12 because 2 x's and 2 y's makes 24, right? So if 2 x's and 2 y's makes 24, half that many makes 12. So x plus y will make 12. In other words, they make up the sides. X and y represent the side lengths of the rectangle. Hey, what did x and y represent in the other one? Angle. They represented the sides. Let's write that up here too. X and Y represent the sides of the rectangle. Notice X and Y represent the same thing in both equations. Well, that means if I can find X and Y's that work for this one and for this one, in this equation and in that equation, then I would have something that makes this true and that true about the same rectangle, like one rectangle that represents both of those things. So notice the red line keeps track of all the things that work for the first equation, and the blue line keeps track of all the things that work for the second equation. Notice there's only one place that's on both lines, 210. Okay, so 210 is the only place where we have both things work. Now we can show that this is true by plugging them in. You can plug in 2 for X, 10 here, and 2 there. And you'll find that it works. Watch. I'll do the Y, the first one, 10 equals 3 times 2 plus 4. 10 equals 6 plus 4. Oh my gosh, 6 plus 4 is 10. Wow. And 2 times 10 plus 2 times 2 equals 24. That's true as well. 20 plus 4 does indeed equal 24. So notice, for all of these, both equations, this right here is the solution. That's what we define as the solution. It's the thing that makes both of these equations true at once. And we would say that the solution is 210 as a point, or you could write X equals 2 and Y equals 10. But why would I do that if I could just, oops, that's not a 10. Why would I do that if I could just write a point? It's much faster just to write 2, 10. So often we'll just write it that way as a point. That's all you need to do for now. We're going to talk about ways to solve this we already have in class, but now you have the answers for this assignment. Good job. Have a wonderful